So during last lecture, we have seen the derivation of Airy stress function. Is it okay? Are you familiar with Airy stress function?
Yes,
So
sir.
please participate. Are you familiar with Airy stress function? Do you know the concept of Airy stress function, everybody? Airy stress function, this concept is known, everybody? Harshvardhan,
Yes, sir.
Manoj Kharat,
Uh,
Airy stress function. Do you familiar with this concept of Airy stress function? Have you seen during last lecture about this del square phi is equal to 0? Del square phi is equal to 0, or this final equation del raised to dou 4 phi dou x4 plus 2 times of dou 4 phi dou 2x dou y2 dou 4 phi dou y4 is equal to 0. Are you familiar with this equation, Manoj Kharat?
yes, sir. Yes, sir.
Yes. So this equation is nothing but what is the name of this equation? What is this equation? This equation is nothing but Airy stress function, the proof of Airy stress function, and this equation represents del raised to 4 phi is equal to 0, and that is the essential condition for Airy stress function. So during last lecture, we seen this particular del raised to 4 phi here is equal to 0. So we have proved this concept, and for that purpose we used the previous concepts related with the equilibrium equation, then relation between the elastic constants with this equation. So with this Airy stress function now, we have last lecture we have seen that how to solve a few examples of Airy stress function. Suppose phi is the Airy stress function, then first of all, how to check that this function or this example of Cartesian coordinate system, is it possible to solve this equation with the help of Airy stress function or not? What is the essential condition? Essential condition is that if del raised to 4 phi is equal to 0, then this example, this equation can be solved by the concept of Airy stress function. Is it okay? Here in this equation, now phi is equal to ax square plus by square. So this is the first example given here. And second example, phi is equal to ax cube. This example is given. The third example, in that phi is equal to a into bracket x raised to 4 minus 3x square y square is given. And now one by one, each example we are going to solve here in order to find the stresses sigma x, sigma y, and at the same time, in order to find the essential condition that whether the function can be solved by Airy stress function or not. Is it okay? So for that purpose, the first example, if we take phi is equal to ax square plus by square, then what is the essential condition? How to check that this equation can be solved with the help of Airy stress function? Anybody? What is the essential condition in order to check that this function, this particular problem can be solved by Airy stress function or not? What is the essential condition? Anybody? Essential condition काय आहे याच्यामध्ये? हर्षवर्धन?
सर सेंट वेनंट प्रिन्सिपल म्हणजे बॉडी कंटिन्युअस असावी.
That is that things are assumptions of theory of elasticity or the Airy stress function, etc. But essentially, we are initially finding del raised to 4 pi. If del raised to 4 pi is equal to 0, then and then only this example can be solved by using the concept of Airy stress function. Is it okay? Because in previous example here, we have proved, here we can see that this bracket del raised to 4 phi is equal to 0. Is it? Are you observing this? Del raised to 4 phi is equal to 0. Is it okay?
Yes,
This
sir.
thing we have proved during last lecture. So that indicates that if del raised to 4 pi is equal to 0, then this function can be solved by using Airy. This particular example can be solved with the help of concept of Airy stress function. Is it okay? So this is the first thing, and for that purpose we have proved del raised to 4 pi is equal to 0. This concept is also proved. So first of all, anybody before start of this example, we should have to prove that del raised to 4 pi is equal to 0, and if it is proved, then definitely this example is under Airy stress function, and by using the concept of stress strain we can solve them. Is it okay? So now let us take the first example. Phi is equal to ax square plus by square, and then let us differentiate this equation with respect to x. So if we are differentiating this equation with respect to x, then dou phi by dou x. So definitely what is going to happen to the right side? Differentiation of ax square, for that purpose 2ax. So that is the differentiation. The remaining plus and this remaining quantity, so that will be considered to be equal to 0. So b is already constant. Y is with reference to x, as this is partial differentiation equation, so y will be considered to be constant, and then by square, this total term will be considered to be constant. So plus constant term, that's why its derivative will be equal to 0, and derivative of ax square will be 2ax. So dou phi by dou x will be here 2ax. Here we can see this. With definition of Airy stress function, how we have identified sigma xx? Bhushan, Manoj, what is the sigma xx as per Airy stress function? As per Airy stress function, what is sigma xx and what is sigma yy? With the definition of Airy stress function. Manoj Kharat. What is sigma xx and what is sigma yy for Airy stress function? Okay. Harshvardhan.
Sir del square phi by dou dou square phi by dou y square
Correct.
sigma x. Sigma y by dou square phi by dou x square.
Yes. So sigma yy is dou 2 phi by dou x2, and sigma xx is equal to dou 2 phi by dou y2. So that is the simple definition. And in order to identify shear stress sigma xy minus dou 2 phi by dou x dou y. Is it okay? So that is the definition of sigma xx, sigma yy, and sigma xy here. So these things we have to refer here also. So here differentiating phi with respect to x, dou phi by dou x, which is equal to 2 times of ax. If we differentiate this dou phi by dou x one more time, then that will become dou 2 phi by dou x2, and this dou 2 phi by dou x2 is nothing but sigma yy. Is it okay? So try to understand here what is sigma yy, because as per the definition of Airy stress function, already we have defined the term that dou 2 phi by dou x2 is nothing but sigma yy. So let us differentiate this first of all, dou phi by dou x. Here after differentiating this dou 2 phi by dou x2 to the left side and to the right side, Once again it is differentiated with respect to x, that will become 2a, because 2ax differentiated with respect to x, we got here 2a. So sigma yy is equal to 2 times of a. So that we can see here in this step. Is it okay? Then if we consider the second point, dou phi by dou y. So this particular equation, dou phi by dou y, we are differentiating with respect to this function phi, we are differentiating with respect to y. Then dou phi by dou y, so it will become equal to, so this with reference to this function as we are differentiating with respect to y, that's why ax square, this will be constant, and by square, for that purpose differentiating with respect to y, this will become 2 times of by. Is it okay? So 2 times of by, that will become equal to dou phi by dou y. So differentiating this phi with respect to y, we got dou phi by dou y is equal to 2 times of by. Now let us differentiate once again this equation with respect to y, then it becomes dou 2 phi by dou y2. Is it okay? So this will become equal to now 2b. Once again this is differentiated with respect to y, this become dou 2 phi by dou y2. Then this is 2b. So what is dou 2 phi by dou y2? Manoj Kharat. Dou 2 phi by dou y2.
Sigma xs.
That is sigma x. Very good. So dou 2 phi by dou y2 is nothing but sigma xx, and sigma xx is the stress along x-axis. Initially this sigma yy has been identified. So sigma yy is the stress along y-axis, and sigma xx will be stress along x-axis. So for this example, when function phi is equal to ax square plus by square is the function given, then its a stress along y-axis will be equal to 2a, and stress along x-axis dou 2 phi by dou y2, this will be equal to 2b here. Is it okay? Let us try to identify sigma xy, because sigma xy is equal to Bhushan Sawan. What is sigma xy? Am I audible, Bhushan? Am I audible? Yes. Are you present to the lecture? Are you present in lecture, Bhushan? Okay, you just reply me that what is sigma xy. Sigma xy is, just type here, sigma xy is shear stress, and shear stress is given as dou 2 phi by dou x dou y. Is it okay? So suppose this particular equation dou phi by dou x is equal to 2ax, then differentiating with respect to y, this will become dou 2 phi by dou x dou y, and this right side 2ax, that will become 0, because this particular equation sigma dou phi by dou x is a 2ax, and after differentiating with respect to y, this dou 2 phi by dou x dou y becomes equal to 0, and then we may say here that stress along y-axis is 2a, stress along x-axis is 2b, and shear stress sigma xy is equal to 0. So like this first example we have solved here. Is it okay? So here cumulatively this condition is written here: sigma xx is equal to 2b, sigma yy is equal to 2a, and sigma xy is equal to 0. Is it okay? But for we are giving this value sigma xx, sigma yy, and sigma xy, but still here it is one thing important, that we will have to check whether the biharmonic condition is achieving or not. So what is the biharmonic condition here? So for biharmonic condition, we should refer here del square into bracket del square phi is equal to 0. See, this is the biharmonic condition, which is essential condition. If this condition has been validated, then and then only this example is under the Airy stress function, and then only our values of sigma xx, sigma yy, and sigma xy is equal to 0. So let us check whether that del square in bracket del square phi is equal to 0 or not, or del raised to 4 phi is equal to 0 or not. What is del raised to 4 phi? Del raised to 4 pi in this del raised to 4 pi upon dou x4 plus del raised to 4 pi dou raised to 4 pi upon dou y4 plus minus 2 times of dou raised to 4 pi dou x dou y. So let us check here. Already this dou phi this dou phi 2 upon dou x dou y, or dou phi by dou x is equal to 2ax, and dou 2 phi by dou x2 is equal to 2a. Let us differentiate this particular equation with respect to x again. This will become dou 3 phi by dou x3, and that will be equal to 0 here. Dou 3 phi upon dou x3 is equal to 0, and definitely dou raised to 4 pi upon dou x4 is equal to 0 then. Is it okay? Similarly, if we took the dou 2 phi by dou y2 is equal to 2b, it is at it a constant, then let us differentiate with respect to y again. So dou 3 phi by dou y3, then this will be equal to 0 here only. Definitely dou raised to 4 pi upon dou y4 is equal to 0 here. So dou raised to 4 pi dou x raised to 4 is 0. Dou raised to 4 pi dou y raised to 4 is equal to 0. This dou square phi upon dou x dou y, this is already 0 here. That means dou raised to 4 phi dou x to dou y2 will be also definitely equal to 0, and that's why del raised to 4 phi is equal to 0. This condition has been achieved, which is the biharmonic condition, and this shows that phi is the Airy stress function. We can say the function phi as Airy stress function because our condition of del raised to 4 phi is equal to 0, that condition is validated here. That is, the biharmonic condition is here, and that's why we consider that biharmonic condition has been achieved, and whatever the values of stresses sigma xx, sigma yy, that are correct values now. Is it okay? Now let us check once again the next example. Here we are considering phi is equal to ax cube. Then let us differentiate this phi with respect to x. First of all, this will become equal to dou phi by dou x is equal to, after differentiating, this will become 3 times of ax square. Is it okay? So let us check this. Phi is equal to ax cube. Then let us check, let us differentiate with respect to x. We will get dou phi by dou x is equal to 3ax square. Once again differentiate with respect to x again, that will become dou 2 phi by dou x2, and then it will become, so this 3 into 2 6ax. So dou 2 phi by dou x2, once again as rightly answered in previous example, dou 2 phi by dou x2 is nothing but sigma yy. Is it okay? So this sigma yy, or the stress along y axis, that is going to equal to 6ax. So that you should understand here. Is it okay? Now, as there is no y term present in this phi, so that's why if we differentiate this phi with respect to y, dou phi by dou y definitely is equal to 0, because no y term present here. As a partial differentiation, we are taking with respect to y only. So dou phi by dou y, for that purpose this equation in y term is not present, this will become equal to 0. So dou phi by dou y is equal to 0. Definitely dou 2 phi by dou y2 will be also equal to 0 here. So what is the meaning of that? Dou 2 phi by dou y2 is equal to 0. What it means? It means that the sigma xx is also equal to 0. Sigma xx is equal to 0. So first of all, dou 2 phi by dou x2 is sigma yy, and second one, dou 2 phi by dou y2, that is sigma xx. So in this example, the stress along x-axis is equal to 6ax and stress along y-axis is equal to 0. Is it okay? So like this, let us understand the concept of stresses sigma xx and sigma yy here only. Then sigma xy. So for this sigma xy minus dou 2 phi by dou x dou y, that is the sigma xy. If we differentiate dou phi by dou y with respect to dou x, definitely this dou 2 phi by dou x dou y will be equal to 0. That means that sigma xy is equal to 0. That means that again, cumulatively, if we try to write here, we will get that sigma xx is equal to 0, sigma yy, that is equal to 6ax, and sigma ax is equal to 0. Stress along y-axis is 6ax, stress along x-axis is equal to 0, and stress along xy, shear stress, that will be equal to 0. The values of sigma xx, sigma yy, and sigma xy we have identified, but we have not seen the biharmonic condition. So biharmonically, we will have to check the essential condition that del raised to 4 phi is equal to 0 or not. And for that purpose, let us see here that how this del raised to 4 phi is equal to coming equal to 0 or not. So for that purpose, let us have, so del raised to 2 phi dou y2 is already 0 here. That means it's a second degree is equal to 0. Then it's a fourth degree, that will be also equal to 0. Here dou 2 phi by dou x2 is present already. If we take once again one differentiation, dou 3 phi by dou x3, that will become equal to 6a, and dou raised to 4 phi upon dou x4, that will be equal to 0 because 6a is the constant. So dou 4 phi by dou x4 will be 0, dou 4 phi by dou y4 will be equal to 0, and definitely intermediate term, that is dou raised to 4 pi dou x2 dou y2, that is going to become 0 because this term is 0 again here. So here the essential condition of del raised to 4 pi is equal to 0, that has been achieved, and that indicates that this particular condition of biharmonic has been satisfied, and the function is Airy stress function, and the value of stress along x-axis, stress along y-axis, and shear stress. So for that purpose, now let us try to plot the equation here. We are getting sigma yy is equal to 6xax, sigma xx is already 0, sigma xy is already 0. So this sigma yy is equal to 6ax. So sigma yy is equal to 6ax. So let us consider this as a constant. This is the constant term 6a, and it is changing with respect to x only. So 6a part is constant and x is variable. So sigma yy is equal to 6ax. That means as x increases, sigma yy increases. 6a is being constant. So when x is equal to 0, y is equal to, or sigma yy is equal to 0. So that's why when x is considered to be 0 here at its origin, if we consider that x is equal to 0 here, then sigma yy is also equal to 0. But as x starts to increase 1, 2, 3, 4, 5, 6 like this, six times of 1, 6 times of means 6a, 12a, 18a, like this. So when we change x by 1, 2, 3, 4, 5 like this, so sigma yy will change like 6, 12, 18, 24 like this times of a. So that's why this will be again changing on positive x-axis, and that's why this graph we try to plot here as shown here. If we are trying to plot the graph, then that graph becomes like this. So sigma yy, which is equal to sigma ax, or that this constant line will be observed here. Is it okay? So let us understand This is the second example of Airy stress function, so which is solved here. Is it okay? Now let us go to this third example. So in third example, what is present here? Let us check. That is in third example, phi is equal to ax raised to 4 minus 3ax square y square. I think all of you have seen this example. You all of you can see this example on your screen. So phi is equal to ax raised to 4 minus 3a x square y square. So let us go one by one by following the rules of Airy stress function. Again, now these are very simple things. All of you know that initially we are going to identify do sigma xx, then sigma yy, then sigma xy, and for that purpose, essential condition is biharmonic condition, that whether this particular function del raised to 4 pi is equal to 0 or not. If del raised to 4 pi is equal to 0, then and then only we can say that this equation follows the essential condition, biharmonic condition, and then this can be solved by Airy stress function. Is it okay? So let us one by one check all the things. So first of all, let us differentiate this equation phi with respect to x. So dou phi by dou x is equal to x raised to 4. That means let us differentiate with respect to x, 4a x cube. Is it okay? So 4a x cube, that is differentiated with this phi function is differentiated with respect to x, and that will be equal to 4a x cube. And then the second term, for this second term again differentiate with respect to x, and we will get here 3a as a constant, x square, differentiating x square, it will be 2x, and then y square will be as it is. So 2x, that 2 into 3, that will become equal to 6. So 6a x y square. Here you can see that after first differentiation of this phi, we got dou phi by dou x is equal to 4a x cube minus 6a xy square. So that is the first differentiation of phi with respect to x. Now let us differentiate this dou phi by dou x once again with respect to x. So after differentiation this function with respect to x once again, dou 2 phi by dou x2. So this is differentiated once again with respect to x, then it is equal to, so 4 into this 3 will become 12. So 12ax square, because it is x cube, this will become x square after differentiation. So 4 into 3, this become equal to 12ax square minus, now this term y square and 6a, all these will be considered to be constant because we are differentiating with respect to x. So that's why 6a is constant and y square is also constant. Only variable term will be x. Here we are differentiating. This is a partial differential equation. So that's why here only 6ay square, that constant will remain, and x raised to 1. So that will become x raised to 0, or this term will get vanished. This will be equal to 1. And then dou 2 phi by dou x2 will be equal to 12ax square minus 6a y square. Is it okay? So again we know that dou 2 phi by dou x2 is nothing but equal to sigma yy. So sigma yy is equal to 12ax square minus 6a y square. Is it okay? So try to understand this thing here. So you will come to know that this stress along y axis is equal to 12ax square minus 6ay square. Then again, let us check here that dou phi by dou y. So for differentiating this function again with respect to y here, as this total term in which y is not present, this will be considered to be equal to constant, and that is going to convert equal to 0. Minus term, now we are differentiating with respect to y, so y square will be equal to 2y. After this taking the differentiation, because this 3ax square, so 3ax square, this will be constant term. Only y square will be get converted into 2 times of y. So 3 into 2, that will be equal to 6ax square y. So let us check here. So dou phi by dou y, that means we are differentiating with respect to y. This first term will become equal to 0. This will become equal to 6ax square y. Okay. So like this, minus 6ax square y, that is dou phi by dou y. Now that is again differentiated with respect to y. What we will get? Dou 2 phi by dou y2, then that will be equal to, after differentiating this term again differentiated with respect to y here, what we get? Minus 6ax square. Is it okay? This y being variable and remaining term being constant, minus 6ax square, and that is dou 2 phi by dou y2, and then dou 2 phi by dou y2 is nothing but sigma xx. So that's why the stress along x-axis will be regarded here it as 6ax square, and the stress along y-axis, which is considered to be 12ax square minus 6ay square. Is it okay? Now let us differentiate this dou 2 phi by dou y2 once again. Then we will get dou 3 phi by dou y3. So there is no term of y present here. So that's why in third differentiation only this term will become equal to 0. So that's why definitely del raised to 4 phi upon dou y4 is going to equal to 0 here. Is it okay? So del raised to 4 phi upon dou y4 is equal to 0 here. That indicates that the first term in del raised to 4 phi, that is equal to 0. Now let us check del raised to 4 phi by dou x4, what the value comes. So for that purpose, once again differentiate that dou 2 phi by dou x2 with respect to x again. So dou 3 phi by dou x3, that will be the third differentiation. In that third differentiation, definitely this minus and remaining term will be equal to 0, because after differentiating this term with respect to x, this will be regarded as constant. But if we differentiate this term here, dou 3 phi by dou x2 will be equal to 12 into 2 is equal to 24ax. Okay, so dou 3 phi by dou x3 is equal to 24ax. And once again, if we differentiate this dou 3 phi by dou x4, means if we differentiate this particular term with respect to x again, that will be dou 4 phi by dou x raised to 4, and that will be 24a, because this x, that will vanish after differentiating this term 24ax with respect to x. Then del raised to 4 pi dou x4 will be equal to 24a. Is it okay? So like this here it is given. Del raised to 4 pi dou x raised to 4 is equal to 24a. Is it okay? So now let us differentiate this particular term dou 2 phi by dou x2 with respect to y, because now we want dou 4 phi by dou x2 dou y2, and for that purpose we need to differentiate this particular term with respect to y. We will get dou 3 phi by dou x2 dou y. So this particular first term, that is going to become equal to 0, because there is no y term here, only x term is present. That's why 12ax square will be equal to 0 here. What will be effect on this minus and remaining term? With reference to y, if we differentiate, then this will be equal to minus 12 ay. Okay, so this will be equal to minus 12 ay here. Okay. So minus 12 ay. So that is dou 2 phi by dou x2 dou y minus 12 ay. This is the term present here. Once again, if we differentiate this with respect to y, this will become dou 2 4 by dou y4, and then this will become only minus 12a. Is it okay? So like this, dou raised to 4 pi dou x2 dou y2 will be equal to minus 12a. Okay. Now, if we are considering del raised to 4 phi is equal to 0, that indicates that del raised square in bracket del square phi is equal to 0. That means if we expand this bracket, or if we write in the form of dou function, then dou raised to 4 pi dou x4 plus 2 times of dou raised to 4 pi dou x2 dou y2 plus dou 4 pi dou y4. Let us substitute this dou 4 phi upon dou x4 is equal to 24a. Let us substitute this dou 4 phi by dou x2 dou y2 as a minus 12a, which has been identified here. And then dou raised to 4 pi dou y4 is equal to 0. So let us substitute one by one here. So this first term is equal to 24a. Second term is 2 times of minus 12a, that is minus 24a. So plus 24a plus minus 24a, that is 24a minus 24a, this will become equal to 0. This indicates that the biharmonic condition is fulfilled here. That means this function is Airy stress function, and then whatever the evaluated values of stress sigma xx and sigma yy, so that are correct here. But now we have to plot it. Okay, so we are going to plot this. Then, in order to plot this particular equation here, the sigma x and sigma yy that we are going to use, then let us first of all identify sigma xx. So sigma xx value is present here, which is minus 6a minus 6ax square, minus 6x square, that is the parabolic function. So this parabolic function, and again it is negative sign, indicates that this is going to enhance in the negative direction. So first of all, minus 6a, if x is equal to 1, then minus 6a if it is 2, then 4 into 6, 20, minus 24a, then for 3, 9 into 6, 56a, like this. This is going to change in negative x-axis direction. So as x changes from 1, 2, 3, 4 like this, the sigma xx value is going to change in negative direction. So that's why the relation of sigma xx, for that purpose, this function as a parabolic function, and here it is shown, the sigma xx values. So that can be plotted approximately by this way. Now let us try to identify sigma yy. For sigma yy, again here 12ax square and minus 6ay square, both terms are present. So that means this particular sigma yy is dependent on both x as well as y. So previously this sigma xx, plotting of sigma xx is quite easy because this is dependent on only with x. But here that is dependent on both x as well as y. So that's why here we'll have to assume one by one the value. Suppose x and y both are 0, sigma yy is equal to 0. When x becomes 1, y is equal to 0, then 12ax square. If x is equal to 0 and y is equal to 1, then it is minus 6y square. So like this, if the value of x and y both are 1, 1, then 12a minus 6a, that is the 6a. So for similar value of x and y, that is in positive direction, so this will propagate in positive x-axis direction, and that's why this particular function, by substituting approximate values of x and y, it will propagate in positive x-axis direction, and that's why this equation, as again this is square term, in both cases square term is present, that is parabolic in nature, so this will be propagate in this direction. Is it okay? So we should be able to plot the diagram also. Is it okay? So one more equation of Airy stress function and this polynomial equation that we are going to finish in the next lecture. So here with this equation we will stop here. So anybody, any kind of any doubts for this? Any doubts, anybody?